In this question, we're told that the random variable x is normally distributed with a mean of 79 and variance 144. Before we get started on the question, the first thing we should do is to define the distribution. So x follows a normal of 79 for the mean, and be careful here that you recognize the variance is 144, so the standard deviation is 12, and we're writing 12 squared. In part A, we're asked to find the probability that x is less than 70. Okay, quickly on a diagram, 79 being at the middle, and we're looking for the probability that x is less than 70. According to the diagram, this should be a small probability, as in smaller than 0.5. Let's make sure we get that in our calculation. So we can use the cumulative distribution function, choosing an arbitrarily small minimum value, so we can take the lowest tail to be negative 1000. The maximum we're interested in is 70, standard deviation of 12, and a mean of 79. All of this can go into your calculator, and we get an answer of 0.2266. And that fits in with our sense check. We expected it to be smaller than 50%, and it is. In part B of the question, we're asked to find the probability that x is between 64 and 96. We can once again use the cumulative normal distribution function, entering 64 as the minimum, 96 as the maximum, 12 as the standard deviation, and 79 as the mean. Okay, and just into our calculators, and we get an answer of 0.8161. Part C gives us a diagram to work with, and we're told that it's known that the probability of being in between 79 minus A and 79 plus B is 0.6463. And that information is shown in the diagram below. We're also given the fact that the probability that x is greater than 79 plus B, so that's the section off towards the right hand side, equals twice the probability that x is less than or equal to 79 minus A. So it's twice as big as the shaded region. So this highlighted area is twice the size of the shaded area. Okay, what can we do with this? Here I'm generating a statement where the highlighted area plus the shaded area should equal 1 minus the 0.6463, 1 minus the unshaded area, the white area. Okay, that makes sense. All three of those regions would add up to 1, and we've just done some rearranging. Well, since we know the highlighted area is actually twice of the shaded area, I'm going to do a substitution here and swap that expression for 2 times the shaded area. So 2 of the shaded area plus 1 of the shaded area equals 0.3537. 3 shaded areas is 0.3537. 1 shaded area, 0.1179. And this is what the question wanted us to show. In part D, we're asked to find the value of B. So the highlighted area's boundary was B units above 79. I'm going to start with this statement. The probability that x is less than or equal to that boundary value, 79 plus B, is going to equal the shaded area plus the unshaded. It's going to equal 0.1179 plus 0.6463. If we add those together, we've got 0.7642. This statement is very useful. Here, we've got it in the form that we need to use the inverse function. This unknown value, 79 plus B, I can find that by using the inverse, the probability on the left of this value that I'm interested in, the standard deviation, and the mean. And from that, we get an answer of 87.639. So, rearranging, we get B equals 8.639. Okay, there was nothing in the question saying that it must be an integer or the nearest integer, so I'm happy to leave it in this decimal form.